Planet Earth is the largest and most well-known habitable planet. But what is a habitable planet? What makes up a habitable planet? To understand this, we must first understand what a habitable zone is. A habitable zone is the range of orbits around a star within which a planetary surface can support liquid water given sufficient atmospheric pressure. More simply, a region that exhibits the necessary conditions to support all types of life forms. Before diving into what the necessary conditions are, it is necessary to divulge into the process of life being formed and maintained.
Life by no means has a concrete definition. However, a good description of life revolves around 7 certain characteristics proposed as criteria for life. These include reproduction. Living organisms must be capable of reproducing either sexually or asexually. The process of homeostasis is also important, where maintaining a stable internal environment is crucial for life. Living organisms must be able to respond to internal and external forces put upon them. Life also needs to be able to grow and develop, as cells must have the necessary physiological features to survive. Genetic information of a living organism must be passed from cell to cell, through generation to generation. Metabolism, formally defined as a collection of chemical reactions occurring within a cell. These reactions vary in form and function, but promote many life-sustaining processes, for example, protein synthesis, thus are especially crucial to sustaining life. And finally, cell organisation through chemical and genetic makeup is also important for life. Living things are made of cells, as cells are the most basic unit of life. Living organisms often need the fundamental chemicals of life. Carbon, oxygen, hydrogen, and nitrogen all support life's metabolic processes, and thus living organisms are able to be sustained.
The fundamental criteria points published by NASA on what defines a habitable zone are threefold. The first criteria point, and arguably the most important, is the presence of extended regions of liquid water. Liquid water is essential to living organisms here on Earth. Since water is essential for life on Earth, it can be hypothesized that life on other habitable zones share this requirement. The second key criteria point surrounds conditions favourable for assembly of complex organic molecules. Essential elements like carbon found in these rocks and nitrogen found in the atmosphere play a pivotal role in supporting and maintaining life. Essential minerals and organic and inorganic compounds are necessary for life. The surrounding substrate, like rocks and soils of a habitable zone, play a pivotal role in supporting life. In order for living organisms to prosper in a habitable zone, transport mediums are highly necessary. The flowing water in this stream, for instance, accommodates many organisms that can support life. Atmospheric conditions, like the strong southwesterly breeze that's happening here today, can play a key role in determining the environment and climate. The variability of a climate in a habitable zone means that living organisms need to adapt in order to survive and prosper. This tree is a prime example of that. The third and final criteria point is around energy sources to sustain metabolism. Life on Earth uses 2 sources for energy: sunlight and redox chemistry. A habitable zone must have enough sunlight to accommodate metabolic processes. For instance, photosynthesis have appropriate mediums to accommodate redox reactions, i.e. in the soil that you're in or in the water. The habitable zone is in the vicinity of a star. It's important to factor in the distance away from that star. If the distance is too far, there won't be enough light to accommodate such metabolic processes like photosynthesis to support life. If the distance is too close, excessive light through forms like UV radiation would cause the living conditions to be too harsh. Thus, organisms would not be able to survive. Another consideration of a habitable planet is atmospheric conditions. In order for a suitable habitable planet to exist, It must exhibit atmospheric conditions that traps heat, shields the surface from harmful radiation, and provides chemicals needed for life, such as carbon dioxide and nitrogen. The habitable planet must also have sufficient gravity to hold an atmosphere. This would allow gas molecules to be trapped, leaving the planet a sufficient protective shield. Take Earth for example. Earth's atmosphere is relatively stable at about 160 kilometres thick. The atmosphere keeps the surface warm and protects it from radiation. It also has nitrogen and carbon dioxide readily available, as well as a sufficient gravitational profile to support an abundance of life forms. It's well known that life is relatively limited to a temperature range between -15 and 115 degrees Celsius. Thus, atmospheric conditions that support the existence of temperatures in this range should exist on the habitable planet. Changing atmospheric conditions can often be detrimental to life forms, as those life forms that inhabit a planet have prominent physiological features to thrive in stable conditions. Changing of atmospheric conditions can often cause life forms to die, thus the species' inhabitability is negatively affected. In order for a planet to be habitable and thus support the presence of sustainable life, certain compositional and topographical features are required. A habitable planet should hold an atmosphere, for reasons mentioned previously. It also has to be a comfortable distance away from the star in a habitable zone. If it is too close, it will be in a heavy heat and radiation zone, which is too much to sustain life. If it is too far away, the planetary climate will be too cold and there will not be enough light to sustain habitability. A habitable planet should have a molten core, as it provides a source of geothermal energy. It also allows cycling of raw materials, and it sets up a magnetic field around a planet that protects living organisms from harmful radiation, thus promoting habitability. A habitable planet must rotate on its axis and revolve. If there's little to no axial tilt, there will be no variation in climates that mimic seasonal change on Earth. The planets will therefore be too cold to sustain life. If a planet is radically tilted, seasons will be too extreme and make it much more difficult for the biosphere to achieve homeostasis. Thus, appropriate axis rotation is necessary for planet habitability. To be habitable, it should contain rock as part of its composition, as well as the 4 fundamental chemicals of life: carbon, oxygen, nitrogen and hydrogen. The minerals in rock and these fundamental chemicals support life's metabolic processes, and thus living organisms are able to be sustained. There you have it, my idea of a habitable planet. What's yours?